All right, so today we're going to talk about how to solve these thermochemistry problems. I usually call them specific heat problems because that's really what it's all about, but not necessarily having to find specific heat all the time. So we start with first of all, what is specific heat? So specific heat is pretty much how much energy you need to raise the temperature of 1 gram of any substance by 1 degree Celsius. Everything has a certain specific heat. Water happens to have a specific heat of 4.184 joules over grams times degree Celsius, which is the most common. But there's others that are listed, and you obviously have to look them up. So I'm going to quickly just go over the tutorial on how to do these problems. So this is your main formula on where it shows that you're solving for heat, and heat is equal to mass times change in temperature times specific heat. And you'll notice that that's it, or that should be in your notes. I just kind of broke it down for you, but Q, according to your notes, it's heat energy that's gained or lost, and the units that we use for Q are J, which is joules. M stands for mass. The units we use are grams. Delta T, this little triangle is delta, and it stands for the word change, so it's a change in temperature. That's when they give you two temperatures and you subtract them. In this case, it would be final minus initial, TF minus TI, and we find those numbers in degrees Celsius. And then we have CP, which stands for specific heat, and that one has all the units of the rest of the variables, which is joules over grams times degrees Celsius. Okay, so we take a look at this sample problem. Okay, it says 120 gram sample of aluminum absorbs 9,612 joules of energy. Its temperature increases from 25 degrees Celsius to 115 degrees Celsius. Solve for the specific heat of aluminum. Okay, so first of all, something that I would suggest you doing is going through the problem and underlining anything that has a number. So first thing is 120 grams, and if you take notice of what I had written over here, if it's grams, then you know that that's gonna stand for your mass. So I mean, you can even kind of indicate in the problem that's your mass. Of aluminum absorbs 9,612 joules. Okay, joules, if we look at this information, which should also be in your notes, joules stands for Q, which is heat energy loss. So that's going to be my Q. And then I can even say, instead of mass, just saying this is my M. Its temperature increases from 25 degrees Celsius to 115 degrees Celsius. So it's saying that it starts from here and ends from here. So this is technically TF, and this is TI. Solve for the specific heat. So we know specific heat is CP, and CP is what they're asking us to find. Okay, so other than the fact that we already know that we're trying to find specific heat, so this is a formula that they give us. We have to keep in mind something that I told you, that if it's a number that has joules, that's Q. If it's a number that has grams behind it, or the units grams, that's mass. The units of degrees Celsius, that's temperature, and any unit or any number with the unit joules over grams times degrees Celsius, that's specific heat, which gives us our formula. Okay, if we wanted to algebraically manipulate the formula so that we know how to set it up when we're solving it. So if we are trying to look for M, we're going to isolate M by bringing any other variables to the other side. So in this case, that would be the formula for mass. If we're trying to find delta T, again, we're going to isolate it, keep it by itself. We bring these other two to the bottom side of the other side. And then, so that would be the formula for delta T. And then last but not least, specific heat. If we're trying to find that, we isolate specific heat, leave it by itself, so we bring the other two variables to the bottom and underneath the Q. So if you notice, for all of them, Q is on top, and then the other variables come underneath it. Okay, so in this case, for this problem, we're using this particular formula. Okay, the thing you might want to keep in mind is knowing, remember I had labeled the question where it shows what everything stood for, and that's something you should do so that you don't get confused. But on top of that, I wrote it down to show exactly what every variable stood for. So this was my Q, my M, and my delta T, which I subtracted, and it showed me 90 degrees Celsius. All right, so once you have all the variables done, what you do is you go ahead and plug them into the formula. So there's your Q, and it goes there. Here's your mass, and finally your temperature. So what you're going to do is divide or multiply the bottom two numbers, and you take the top number and divide by the result of that, and then you finally get your final answer. In this case, it's going to be 0.89 joules over grams times degrees Celsius, because these units don't cancel each other out as they're not the same. And that's how you do specific heat.